Hello. Perhaps a bit of a low-key day today. I'm going to see whether I can't get the old fire going. And then derp around in Godot again. I have not updated the stream settings or anything. So that's what it's going to be. Still a little bit warm in there. Enough probably to be able to get this going. So the possibilities today are continue to tinker with the game I'm working on in Godot, or add sound to it. And that could be interesting. It might be worth a try to see whether I can add sound to what I've got. I mean, in theory, that's possible. Yeah, we're all busy this morning doing a bunch of things. I was doing laundry. I was doing a bunch of tinkering with the reverb stuff. Guess I can tell you a little bit about what that was about. So I've been doing an experiment on the reverb stuff. What might this experiment be? Oh, look, I do have a fire going. Good. That's how it's supposed to go. So what experiment might that be? I did my first tries of trying to integrate some of the post-generation calculations into the actual genetic algorithm loop. In other words, moved some of the tests that I'm doing when I'm down to the last 14 over an overnight run and included them in the tests that I do when they're doing 30 million trials over the course of the night. And that's important, because if that works, it gets to use the calculations as part of what it's thinking about to generate a result. I could show you what I did. Hey, Chad. So if I run this, I get to show you what I did. See where it says green RMS times 2? That's the added change being done. And up here, after I do the matrices themselves, this is a loop of matrices, and then so's this. And this stacks up echo returns based on the combined length of all of the delay times being iterated through. So it's just this nested loop, which is why it runs so much faster in C#, I might add. Also, if I was able to simplify any of this down, it would run even faster, because there are so many of this, so many of that if I was able to simplify it, that would make things be better. I don't think there's a way that I can make this any simpler than it is. But immediately after doing that, and I'm going to move on to the video game again soon. Immediately after doing that, I'm defining stuff like green peak is the highest result in those big array values that we're generating. When you see the end result of the into the matrix program, and you know something, I don't think I've actually uploaded that to GitHub anytime recently, so perhaps that's worth a try. Interesting. So what it's doing is it's telling me why I have on stage changes. That is correct, I do. I was just doing a pull on the assumption that it's just part of the routine, that I will just do a pull automatically. Speaking of automatically, I should check the fire and see if that's going. It's kind of not, but it's probably going to pick itself up before terribly long. Git add. Capital A means add everything. So it might be able to pull at this stage, but what I'm going to do instead is go, because nothing will have changed what's sitting up there on GitHub. What I'm going to do instead is go lowercase m for this. Many things have been changed. Many things have been added. I have a whole new 2 files here. And what we're going to do is push that. And that should have it covered. Alrighty, so what you see now and what I'm working with is in fact up on GitHub. So now you get the C# that's running 10 to 100 times faster than the previous one. Assuming, of course, that your personal copies of Godot are able to work with C#. I'm pretty sure there are versions of it that only run GDScript even now. But the Godot mono build, the Godot build that is meant to use C# is able to use C#. So here's what I'm doing with this. We're setting a peak value, and it always has to be 1 because we're going to be dividing by it. And green RMS also, we're going to be dividing a thing. Well, I'm not sure if we're going to be dividing a thing by that. We're going to be adding it. In any case, it's fine for that to be 1. Track RMS is 0. And then we're iterating over the entire array. And as we start, we are just adding whatever we find to track RMS, but we're also tracking what the peak is, because it's going to be all different values, especially with the 6x6 matrix. It generates a dense cluster of values in there. But then as soon as we are past, and you know, these can go up to the thousands and thousands of samples for this little arrangement. They can extend out that far, but, and I see the fire is very leisurely getting started again. It's not terribly cold outside at the moment, so perhaps not as urgent. I'll allow it to keep going in the way that it's going. I'm going to try to keep an eye on that.
as soon as the thing we're iterating over goes beyond 220, watch what happens then. If t minus 220 is larger than 0, I'm starting to subtract what track RMS is, and then I'm also doing a different thing, which is if green RMS, which we have not seen yet, is less than track RMS, then it's equal to this thing that is continuing onwards. What we're doing is we're making a RMS window that continues across the entire length of the decay. And then we're also tracking the peak. This is the kind of thing that I have to measure to be able to do my post-generation stuff. Godot's been using GDScript for a really long time. That was originally what it was all about. It was built in GDScript as well. And it's just always been its jam. So the impressive thing is that they added a more professional programmerly style, manage your own memory style language, rather than one that is as sophisticated as GDScript and also runs kind of slow. And so I've added this to two of the routines. I've got the 6x6 and the 4x4. I'm not really measuring anything else. And I could always add those to the code as well, but for the time being, what I'm doing is just the 6x6s that I'm used to working with. There is a detail that I wouldn't mind looking into. Maybe I'll look into it briefly. Maybe we'll just go and play with the video game. But what's happening when I run this, and there's no harm done firing up the Godot engine itself. And sticking that on screen, and clicking the wrong place and dragging things around. That's not even the one I was thinking I was clicking on. I thought I was clicking on this. No matter, it'll all work. We'll get there. This is a shorter stream because of all the work that I had to do on these reverbs and things. I can show you what it did. Maybe I'll do a bit of that. To do that, I should run Audio Hijack. I'm surprised it didn't tell me about more updates. This program is almost as bad as Discord for telling you that there's updates all the time. And then we set the sound export to SWB audio capture and fire up some of my recently acquired reverbs, in particular stuff from the last day or so. So what we have here, there's a number of things really. Yesterday and today, I was generating reverbs based on the changes I have here. I added this and then started running variations. So I'm going to tell you about the variations that I did. Interesting, Visitrim. So we ran this calculation. And when I say that, what I mean is this calculation is what I added. And that's tracking both the ultimate peak of the delays that we've generated, but also a 220 sample RMS window. It's scaled kind of funny. What I'm going to end up doing at the end here is dividing my end result, which is the maximum RMS, by peak. And it'll still end up being a larger number than the peak, but it'll be scaled to whatever the peak was. So that's essentially doing the same thing that I do in normalizing the audio and then measuring it. It would have been the processing. It would have been this. So you can run this, which, as you can see, that's up here you can see that it's a set of arrays. In fact, it's 1, 2, 3, 4, 5, 6 different arrays, each of which have a specific delay time put into them. And then the way a householder matrix works, I run this twice, one in either direction. That's what the rotated is for. And we're adding up the delay times in each of those and calling the result a total delays from all of the things in the matrix. Because if you're in a householder matrix, you have to go through however many elements in order to get to the end. There is no audio tap from just one of the delays at the beginning and then you're hearing the output. You never get that. Instead, you always get, for a 4x4 matrix, you're going to listen through 4 delays of different sorts. For the 6x6, you're going to listen through 6 delays. And this is what that looks like. So I'm tracking longest and shortest delay of the entire matrix. But then I'm also checking to make sure that we haven't gone beyond the length of the overall array. And then we're adding a fixed number to that, and we're tracking all of those. So then we do this, and I get to record what the largest possible number was out of all of those stacked up reverbs. We're doing stuff based on shooting for the overall delay thing with as few stacked up delays as possible. Like, we're looking for as many of these. I'll run it quickly and you can see. That's a plot. And it is going through a series of, look at it like scan lines. What it really is a really long one-dimensional array. And if we have these sort of faint colored green shades over here, that means one echo. Over here, we always have a bunch of echoes stacked on top of each other because of the way that the numbers come out. Up here, it's very early, and so you start to see more like just one echo again, or like a little blur of them and then another one. There's spaces in between them, especially towards the end. But at the middle, there's never a place where there isn't a bunch of echo returns all landing in the same place. So what I've been doing with running this entire reverb search algorithm is making it so it's looking for the arrangement of the delay times that causes as few stacked upon each other delays as you can get. And you can see from the brightness of the green that sort of at the middle of the delay cloud, that's when most of the delay times are stacking on top of each other. Multiple pass through the delays are ending up with the same result. And my assumption is that's bad. And starts from top left, wraps along like a typewriter would to bottom. It is going from left to right, so it would be bottom right, yes. If it continued onwards, it wouldn't necessarily end with bottom right. It could go this long and end here, and it would still be ending at the final one. You're looking at a 1D array that has been word wrapped, basically. So what I've just changed is as follows. Everything that I have done before was just trying to get the smallest number of the most stacked upon location. The idea was, if you have many of these stacked upon each other, it's because your delay times are all the same or something. There's a weird caveat to that as well. But if your delay times are all basically the same, then you're going to have a sort of nasty metallic effect or sound just like a bunch of echoes, because all the delays will end up in the same place. You want a cloud, you want a diffused kind of noise. And since I'm not using all-pass filters, I don't have anything in here to artificially make it sound more diffused. Now, all-pass filters are extremely normal, but I'm trying to brute force around them. Kinda, sorta user, Giphy, or Gispy. I am in fact using a fitness function, several of them all at the same time, and I am also using genetic algorithm. Mind you, it's mostly based on mutation and less based on inheritance, but I do have some inheritance in here as well. Oh, and how did I come up with all of this? There's a book called Artificial Life, which is fascinating. And I recommend seeking it out and reading it. It's really good. It's done many things along these lines. So what I've added is I'm also iterating through this entire 1D array that's being wrapped like this. I'm watching for the one that is the brightest possible green. It's sort of normalized down so that the brightest possible green is like 256, and it's just designed to be that way. But, and come to think of it, I could tinker with the display part of it a little bit. But you see a degree of orange and blue spots in there. Now some of that, I think I've got the orange and blue spots being prime, but the degree of blueness is also the amount of brightness measurement that's in there. Yeah, Sean's very cool. Everybody loves Sean. I love Sean too. He shares some of his information. He talks about how he goes about doing what he does. I wish he did more of it, honestly. There's a sort of blog post thing that he did in which he was talking about some of his stuff. Now, Sean's stuff is very likely to be also using the normal reverb things of all-pass filters and stuff. People don't normally do these the way I'm doing them, which is a very primitive brute force householder matrix done entirely by echo density and using a genetic algorithm to set the delay times. They are not outputted as I think what you mean is a convolution impulse. No. This is much more efficient than doing a convolution impulse, and it's algorithmic. So if you did a convolution impulse, you'd probably end up making the audio into an FFT, like MP3 kind of stuff, using that to simplify the convolution process, and then outputting the result. And I feel that is much worse, so I don't want to. Schroeder sounds familiar to me. I don't know why you'd call it a B-box. Maybe that's something worth me looking into. But yeah, what I've just added, and I'm going to show you what it got. In fact, I'll be piping it directly through to the stream, unless that part is broken and needs fixing. You'll also see that I've got up to about 200,000 examples at this stage. So you see the basic concept of this is a long 1D array, which is both sides of the reverb combined. I could also be putting stuff in to try to heighten stereo effect. But what I added, what this is doing, is every time I iterate through all of this, we're going through the entire array that was generated by that, and we're keeping a loudest possible single sample, the loudest possible output, and also the loudest possible RMS measurement, which is basically it's basically just a rectangular window. So there's something cute in here, which I will tell you about. And it's something that I've been using. For instance, I've been using it with the the tape compression thing I'm working on, or have worked on and is coming out, uses a series of averaging filters that are also rectangular windows. And you can do a rectangular window really, really cheaply if you're iterating over a long series of samples. You can make your rectangular window measurement for any particular point with only 2 operations. By firstly, you start with adding the variable you're iterating over onto that variable, and then once you've got the window open, as in it's up to, in this case, 220, you're still adding each new one as it comes along, but then you're subtracting whatever was 220 earlier in the list. And so you only have to add 1, and then you subtract 1 from a little while ago. And the thing that you've got sitting there, track RMS, is literally the moving average of that set of samples at any given moment. And you never had to add them all up because it just sort of automatically happened. The trick is you're moving along the array as you go. So you add the thing in the beginning, and then you subtract the one at the end. What you've got in the middle is now an extremely cheap, enormous rectangular averaging filter. Mind you, rectangular window is a very primitive kind of window. There's a bunch of other windows that you can use for combining these samples like this, and they have a lot of validity in measuring stuff. But if you're able to use the rectangular window for this, it's incredibly cheap. What I'm doing with the tape compression idea, specifically, it's modulating a kind of averaging filter that stacks up a lot. And what I'm doing to get that is not this technique, but instead it's keeping a lot of little buffers. And if I always want to have and there's probably a way that I could optimize this even further, but I haven't really found it necessary. If you have a little buffer that is just tracking like 8 samples, your 8 most recent samples, and then you add them together and that's your filtered thing, well, you can be adding the samples together and that's fine. If you add the samples at any given moment, you'll have an accurate result. Whereas if you did this add the most recent and then subtract 8 samples ago, that's doable. That makes sense for a really large Windows, but it can also drift. Like if you're in floating point, if your floating point numbers aren't perfectly accurate, which they're not, then you can get like DC bleed in there. It can drift. But, okay, somebody's asking about Artificial Life by Levy. It would not be Artificial Life, How to Create a Life Computationally by Seiki Adama. I don't know that one, so I don't know whether it's any good. It is here, I can go and show you. Why not? Well, throwing another log on my fire. By the way, this writer is a killer writer. He writes really good stuff. Stephen Levy is one hell of a good writer, and his book Hackers is absolutely worth reading. Makes me want to have gone to MIT. Right. So it's this book. We'll go and show you. This is the one. And yes, it is indeed Artificial Life, Stephen Levy. And it has a lot of interesting stuff in it. Let me see if I can get one of the more amusing visual appearances. Computer-based autocatalytic network consisting of a bunch of stuff. Yep, that's the one. Here's a little graphic of Boids avoiding pillars. Boids has a lot of application to game programming. Cellular automata. It just covers lots of good stuff. Conway's Life. Stable configurations, gliders. I feel like we don't actually have... Yep, and the genetic algorithm is a whole chapter. See, this got me going. This book has been out for a while. Wow, and it is the third book that he wrote. He wrote one called The Unicorn Secret, which I need to read because I don't know what that one is. And then he wrote Hackers, the Heroes of the Computer Revolution, which is awesome. He was writing for Macworld, apparently. Ooh, this other book is apparently called The Unicorn Secret: Murder in the Age of Aquarius. Wow, that sounds exciting. And this is a 1992 book, which just goes to show you. The ideas in that book are driving a lot of this stuff, which is in some ways in advance of whatever people are doing with, like, quote-unquote AI these days. So this is doing a rectangular window, and whatever the end result is, whether it's a large result or a small result, it'll adapt to some extent to what I'm doing. Gets divided by the largest possible sample. And then this is all the stuff about trying to do that basically sea of green graphic that you see, where that's the delay outputs. But then once we've done all of these things, we've generated green, red, and blue, each of which are a different kind of fitness function. I'm adding whatever green RMS is times 2. So what I did was I tried out 3 different variations on this. And I have the audio from them, and I will show it to you now. But this is what I arrived at, was taking most. Most is the end result of all my fitness functions. Everything just pushes against that. And lower is better for most. When numbers go higher, what that means is it's less desirable, and it has to come in lower than whatever the current best was to be kept as the new greatest reverb sound. So first I tried doing most plus equals green RMS times green RMS. I squared the RMS number that I got, which again was scaled back by whatever peak was. And the idea is there's always going to be some of this RMS number, but I want it to be as low as possible relative to whatever peak number survives. If I make it too strong, what's going to happen is it'll just start rewarding large peak numbers so hard that it'll just be like a nasty honk, because the sample returns will all be at the same time. And there's nothing to be gained by having all the sample returns be on the same sample. That would just be one giant echo. So we want some diffusion, but if we have lots of diffusion, that's the RMS being just as loud as the peaks. And what I found in critical listening was that if the RMS is unusually high relative to peaks, stuff sounds closer up. And that is what gave us verb tiny and verb thick. Verb thick is intentionally making the reverb sound closer up. I picked the 4x4 reverb that was as much as possible seeming closer up. So here's the ones that we've done recently. So if I'm not mistaken, and I've saved only the ones that were good, but I ran measurements on like all 14 that I generated and just ran through until I had 10 million runs of each one. And sample time green RMS times green RMS gives me this. See, it sounds a little empty. The distance is not bad though. And it's doing a pretty good job of not sounding too bloomed out and echoey. The distant stuff is quite far away. Well, the next thing that I tried was, and I think this is where we're at, that or yesterday at 8:34, that was before I ran any of these. Yeah, I think maybe this is what I'm talking about. So in that case, this would be no change. Like, this is just stock. And then I added the new stuff, which would have given me, I'm pretty sure it was this too. Yeah, because I got this extremely intense one. See, there's a green, yellow, orange, red. You can't see the red, but that's that many flags. That means it got an exceptionally high score for this. So this would presumably be green RMS times green RMS. So it's a little more sparse. And that sounded pretty cool. I liked it better than the previous ones. I preferred these. Felt a little more tight, felt a little more natural. And then I tried using just green RMS directly, and this gave me way fewer of these higher scoring ones, but I did get a couple. And it registers as yesterday at 5:53 is when those ones got finished. So the interesting thing about this is that it didn't give me as many high scores, but I thought it sounded more natural. Like, it has that weird sort of slightly hollow sound to it, but I thought it sounded kind of more natural than even the previous ones. So then the final ones that I tried were adding square root of green RMS. And these are enormous, huge delays that were also done using just green RMS directly. But then this is square root. Less of an effect. And this is leaning back towards the other one, but not completely. Because the thing is, when you're doing these fitness functions, everything interacts. You'd never be able to calculate it out personally. You're just using the fitness function to sort of get a result. Here's my best performer from there. So that's green RMS, the square root of it. So it is not adding nearly as much of this compared to adding lots of this calculation, just forcing this new value into the fitness function. Which is impressive, but I felt like it got maybe a little exaggerated. And then what I've settled on, I don't actually have any demos of yet, but it is green RMS times 2, rather than either green RMS times itself, which will end up being a very large value. It's putting a sort of exponential curve on the effectiveness of that, or a square root, which is cutting off the effectiveness very radically. And then I have some enormous ones as well. So this is with the RMS stuff included on a much larger reverb sound. And here's larger still. And we're getting into a very distant kind of sound here. Even bigger. Even bigger. And you see the changes in dot color there? Gray is slightly worse than purple. This is one of the ones where the reverb is slightly less RMS heavy. And then we've got an even larger one, except for it's slightly more RMS heavy than the previous one. It isn't as peaky. So that means the sound of the reverb tone feels more forward rather than farther back. And so we get to hear this. And it's all working out fairly well. There's a lot of work to be done with all of this, as you might imagine. If we set up the tags, you see that that one that I just showed is like literally the worst of all of these. But a lot of these were generated with earlier versions of the program. So we got stuff like this. And also with fooling around with the video game, I'm going to be wanting to use a super huge reverb. It'll be a 4x4 rather than one of these, but I'm thinking about also having a tiny one to sound like a spaceship cockpit, so that like little in-cabin sounds would have just a hint of little reverb on them. This being a small room size, not even a cabin size. And a higher performance small room size. Highest performance, yeah. And then if we look into second string, that's all of the ones that I've done up to this point. So as you can see, I've made a whole bunch. Look, here's a super well-performing one from a previous version of this algorithm. It's not half bad. So the whole thing about this is trying to interpret the sounds that they make, but they're all being generated in exactly the same way. They are all just a 6x6 householder reverb with an additional 3x3 tacked on in the front of it, because that's how I do the early reflection stuff. That's how I do position. Look, here's a 171. Definitely a small room. I have one sitting around that I could actually put out. I haven't done anything with it yet. Specifically picked it out because I was like, oh my god, that sounds like a wood room. That sounds like a small wooden room. I bet I could use that. And I think it's still waiting in my upcoming... Yeah, see, K-Wood room. I can put this out. It's ready to go. It's not going to be this weekend. But I did, in fact, come up with one that surprised me in an unusual way because I was like, well, this is not the breakthrough I'm looking for, but this sounds incredibly much like it's a wood-paneled room. That's cool. Let me make that into a reverb now. And so I did. And then I kept moving and kept trying to get something better. But I do get the outliers, yes. Excuse me. Here's my 4x4 matrices. They work a little bit differently because the 4x4 gives me a different sound, but it still follows the same results. It still follows the same rules. So I'll be picking something like this out for counterpart, also known as Never Tell Me the Odds. Now, whether it's that sound or this sound, for the big distance, the asteroid field distance sound, it's not going to be this. See, you were asking about surprising you in unusual ways. Check that out. We've got a slapback verb. It just does that. No delay was added or harmed in the process of building that. It's just one of the options. It's just one of the options that you have. Here's another. Sort of smoother, washier one. We've also got examples of not so distant sounding ones. See, this is still a distant sounding one. Compared to not distant sounding. I'll keep an eye out for strange algos that'll work with that. See, there's another one with slight echoey quality to it. That happens when there aren't enough early reflections in the householder matrix so that you wind up having the soonest event be a pile of echoes piling up on top of each other. You can also get a situation where they're very evenly dispersed, but there's a sort of smooth, diffuse quality to it. This has got a little bit of that, where it doesn't sound anything like realistic, but it does sound very smooth. And apparently that's all I've done with Opacity 4 yet, but second string will contain all of the previous ones that I did. For instance, this is what Verb Tiny has. It's one of the high scorers. That's verb tiny. Now if I wanted an even tinier one, directly above there's a 145 seat and an 82 seat. 82 seat sounds like this. So I'd probably be looking for an even smaller one, and maybe not caring as much about the distant quality. If I sort strictly by numbers, I get something which tends to still sound kind of a lot like a room. This doesn't sound as small as a cockpit, but this is what you would do, possibly just with no feedback would do it. This is what you'd do if you wanted to make noises sound like they were coming from inside a little spaceship cockpit. Yep. So this too could be available. You can get this one at some point. Or this is a little bigger. And then we go all the way to the end, we can have larger ones. And I would have thought I had verb thick hiding in here somewhere. Should be labeled. Oh, there it is. So verb thick is leaning in the other direction. It's trying to sound as good as possible, but the reverb is supposed to sound closer to you rather than being really distant. It's supposed to be merging with the sound form. See, like that. I'm working with the sound density of these reverbs and leaning on stuff that is much more peak heavy or much more RMS heavy to get different sounds, which I think people normally don't even think in those terms. And if they do, they might just go for RMS heavy, so that, or compress or do a variety of things like that to make their reverb sounds sound up front and close. In fact, I think some of Sean from Valhalla, some of Sean Costello's stuff, I think, does that quite a bit. He makes these clouds of reverb that have a beautiful, wonderful texture and don't sound like they're that far away. So I ended up going and working really hard on trying to make everything sound as if it was much farther away. But that doesn't mean that people want their reverb to sound far away. People might want their reverb to sound very close, but have a texture that they like. And then when I find a sound that I like, what I've got is these settings for all of the little, like for the 4x4 reverb, that's 16 little delays. It's all it is. It's 16 little delays arranged in a particular way. But all it is this. I can put it into verb 6s to generate these, but then I can also put that, you could replace what's in verb tiny with any of these and it would still work. Because verb tiny and verb thick are simply 4x4 reverbs. So you could punch this in, everything else would adapt on the fly to fit whatever it is you were trying to do. And then boom, you'd be off and running. It's just D4A through D4P. It's just integer numbers. And each of those numbers represents a delay time that you add. And the way the delay times are combined is a householder matrix. And that's all this is. So each of those sounds are literally just this. They're literally just, and not even the last bit that I highlighted. Literally just the part that I highlighted. It's just a set of integer numbers. And that is just a set of delays. if you had delays available in anything and arranged it in the way that I arranged it into a householder matrix, which means combining them in a certain way, there are patterns that emerge, and some of them are completely weird. It's similar to this book and the way it talks about how genetic algorithm calculations tend to come up with weird, brilliant answers you'd never have guessed, answers that nobody would have attempted because they make no logical sense whatsoever, and yet they just work. I'm going to show you something in my current data, and then we'll go about the Godot hacking. So let's see, I've got that open. Oh, packety. 2026 C# engine. So here's some of the recent ones. I could pick based on ones that sound really good. In fact, maybe that will be a good way of underscoring this. Let's give that a try. Let's go and find one that's amazing. For instance, maybe not this one, but maybe. Let's look into this one. It's 349 seat, 23829. 349. That's probably enough. That's the one. So I'm now covering it with the window. This is the one in question. These are the values we're working with to make that sound. Let's start looking through this for duplicated values. Now, they may or may not be showing up. I've not looked into this before. I do see that D6C 9 and D6I is 3. That's not a duplicated value. We've also got an 81, so those are stacking up on top of each other. And if I was to go through and look, D6T equals 81. But look over here. D6ZD, also 81. So if this was going to be really saucy, it would show me yet another 81. What I found that is completely unexpected is that the ones that perform incredibly well on some of my measurements, like the peak energy stuff, they don't have completely and totally uniform behavior. Instead, some of those numbers will be the same. And that is counterintuitive, and I wouldn't have expected. Oh, and look, I've got an 82. So that's also very near to 81. And I've got another 82. Look at that. We have two pairs of numbers in a householder matrix which has no business having any repeated numbers. So what's going on there is, in generating these, I have the ability to go through and specify, go and evaluate this random bunch of numbers. Oh, but none of them can repeat each other. I can put that in. I can very easily code it so that, generate a bunch of values, organize them in such and so of a way, and then don't have anything repeat. Because logically, you don't want anything to repeat. Because if something repeats, well, it'll end up in the same output numbers, right? Well, maybe not. It probably has to do with the positioning of these duplicated numbers. We've got 281s, we've got 282s, at least 282s, I see 282s. We've got like a 3 and a 9 and an 81, so those are shared like common denominators in there. We've got 69, nice, and 68, by the way. often I would see the smaller numbers, like 3s, being duplicated. So what I'm figuring is, in some way, having these duplicates show up is changing the density of the multiplications. This is just my speculation. I don't know why it's working. It just seems to constantly happen. To the point where at one point I was running these calculations and refusing to evaluate a reverb unless it had a couple of duplicated numbers. At one point I was literally measuring them and checking to see that they were duplicated somewhere. Let's have a look at another. For instance, here, 300 seat. See if we get to it. First of all, that looks about right. Yeah, it was today, so it's one of the last ones I've added. Here's our 300 seat. Here's what it sounded like. And again, you could say, that sounds basically kind of realistic. It's maybe not very spectacular, it's not very sustainy, but it sounds basically realistic. So you go, well, then it must not have any duplicated numbers in its delays, because if it was duplicated numbers in its delays, that would make it sound more like resonances and things. But I think what we're going to find as we look over these numbers, 12, 15, 19, 11, 33, 71, there's a 7 there, there's a 9, oh, there's the other 12. So there's a 12, and there's also a 12. You end up with duplicated numbers. It seems like an iron law. As soon as they sound good, they have at least one pair of duplicated numbers in there. Which ones, I couldn't tell you. I don't know. I don't think you can just write duplicated numbers in there and have it automatically be good. But this is not writing things in to have them be good. This is taking completely random or mostly random trials, going through like 30 million possible trials to find the one that behaves the best according to the fitness function. Still looking at it, seeing whether anything jumps out. Whether anything else jumps out as a repeated number. Did I see 167 somewhere else in there? Yeah, because you would think, if we're combining all of these delays in order to make something that sounds as a uniform wash rather than a series of discrete echoes, the numbers can't ever be the same. And yet what we find, let's look at 341. Or was it 341 I did just look at? Probably not. So here's the highest performance one yet. Arrived at through a really heavy genetic algorithm. Or at least as the Garth Hudson song goes, genetic method. We're evaluating many random options, including ones that are seemingly useless and no good. So 341 seat. And here we are. Let's see what we're seeing. There's 2 3s immediately. One of them's here and one of them's here. At least 2 3s. We only know that there's a pair of 3s. There's a 9, which counts as 3 times 3. So that's fitting in the same basic space. Yeah, and I'm not even calculating out whether any of the larger ones duplicate. It's too hard to keep track of. I'm looking for the smaller ones. So we got 11, 12, and 14, which are pretty closely spaced. Where they sit in the matrix also matters. Like, this is also evaluating where they sit in the matrix rather than just the random numbers being wherever they are. Their position in the matrix does have a significance too. If you think about it, that's fairly obvious. Because, like, if you had 2 3s and a 9 and a 10 and an 11 in one place in the matrix, like if they were all in a row, that would give you an incredibly short delay for that particular echo output. Well, it's an interesting thought, user Gispy. Thing about it is, if you can define, like, to get as close as you can to that, what you do is you define the fitness function to do it. And we're looking at that right now. What we're doing is we're taking random numbers. This gold, silver, bronze, steel, brass, copper is the genetic algorithm part of it. It's keeping the 1, 2, 3, 4, 5, 6 highest performing results. And if it comes up with a new higher performing result, it adds one at the top, and then each successive one becomes the most recent ones. And so it's able to draw from earlier ones, as well as being able to, I could make this a bigger, perhaps not right now. I could make it a bigger list. But this is the genetic algorithm part. It's that each of these, including the way that they are arranged, is saved as the 6 most recent highest scores. And we're able to draw from the previous highest score one, whatever number it had in that position. But it's somewhat randomized. Not in the sense of being a random number or being from a random position, just that at any moment, if we're looking for making the new one, we can pick something completely, 3 and 30, yep, that's times 10. We can always refer to a previous successful design and just grab from there. So one of the things that's happening here is that I'm doing a select, and only if the number being produced is less than 7 do I actually get to go for the previous one. And it might very well be that I could have this be like, okay, if random is larger than, see, because we're doing if select is larger than 7. But we could also do a randomized thing, such as, hang on, don't mind me, just doing some more experiments. If GD dot randf is less than, guess what we do now? We do our trusty golden ratio. So now, mostly it's going to try to draw from previous ones, and only less often will it start attempting to do truly random results. And we can assume that that's a good idea, enough to the point where we include it in, it's going to slow things down a little bit, but this is not actually the slow part of it. See, because what that's doing is that is making it refer to these previously successful ones way more often. And that'll be amusing. That might be a good way to try doing this better. So bada boom. So what do we see when we get this? It's grinding away pretty much about as fast as before, but the funny thing is it looks a little different. In particular, it feels like it has earlier entries happening. So that's neat. I'm curious to see what that sounds like. Up, and as it continues, it's spacing things out a little more differently. Let's stop it right now and see what that was. If I stop it right now, what we're going to see is I'm bringing over the text editor. Hit paste. This is what I got. So what we see is it has not actually arrived at new values for a bunch of these. It's just doing the most recent good score. But a bunch of this stuff is coming from a blank entry. We haven't done enough successful entries to really shake this up very much. So that's quite interesting. That's not going to sound nice, and the reason is because there's way too many of these 3s in here. Now I might be able to fool with that a bit, as long as we're doing it this way. Here's where we defined these, and since they are all 0, then they're all being made to be 3. I am now thinking about what I can do in order to shake this up a bit. Because this is in instantiation, we only have to run this once. I could iterate through this and put in random values rather than having them start out as 0. Or I could make them start out as something unreasonable. Let's give that a try. I don't know whether this is going to let me do what I'm trying to do here. But I tell you, one thing I can do is copy the whole thing and bring it over into the text editor, where I do know that I can change things. Extremely funny that like JetBrains Writer I don't trust to be able to give me a find and replace, but I don't, so there you are. 0, comma gets turned into comma. And we're going to replace all. And then we've got a few leaning over at the end. So what we're going to do is just manual up. Need to not hit anything just then. We're going to manually replace these. And then we're going to paste this all right back where it started. And that should produce an end result that is always going to be pretty bad. And it'll be more easily, it'll work its way through that more easily. So here we are. And that's going to apply to this as well. Boom, and let's see if it runs. Suppose it's possible that it won't run, but now we've made it so that all the numbers that we don't want, that are not actually new and good numbers, are 99999. So it's trying to get down to a size of 500, but it's starting at a size of a kabillion. So it's really struggling at this stage because we're not actually looking at something that's going to be useful. It's trying, I'll give it that, but I think I'm on the wrong track here. In fact, it's not even able to show the numbers I'm looking at. So that's not great. Also, look at how many updates we've had. Update 86. So you see that it's measuring it as 38,000 seat stadium. If I hit stop and write it off as a bad idea, what we'll see is that we still see a bunch of those 9999s in there. And it's trying to get around that by making all the other numbers tiny. What we want is for these all to be numbers of some kind, but not all exactly the same number. So how might we go about that? Like, one possibility is I'm looking at this as this sequence of instantiating things. I can just type in a sequence of numbers and go from there. At which point it'll start out as too small, but it won't be so predictably just everything being 3. And we can run from there. Or we can start with primes. There's no special reason we can't. So back over to here. Back over to grabbing this and pasting it into here, and then doing something more useful with it. So what shall that be? Well, we can go into here. So how many of these do we have after all? One. It's going to be a different number for each of them. When I say it's going to be a different number for each of them, one of these is a 16 count, and one of them is like a 38. So, because they're different sized householder matrices. So they should be different sized arrays too. See, it goes up to 17, but this one goes up to 37. So we use the same thing for each of them. I don't think we have, I don't know whether we have 37 of these in here. But the secret to this is I'd like to copy and paste a new thing into this relevant to each one. And we have this big old line of primes in here. So I could just try that. That's almost certainly more than I need. There's some superfluous spaces in there. Yeah, well, I was going to be doing something else, but we ended up getting derailed into reverb. Nothing so wrong with that. So if I take this and I replace this stuff with this, what we're going to get is new possibilities for it. In fact, I wonder whether I can just overspec it. If I know this is larger than I'm ever going to need, I can simply make arrays that are larger than I'm ever going to need. And it won't be replacing the ones that I don't need. See, we're actively using a certain number of these, but what if we just use an excessively large array for all of them? And then the ones that don't need to get updated are the ones that won't be updated. So watch this. it should adapt itself pretty well to both sizes of householder matrix. Because this is almost certainly, I didn't count them. Actually, one thing I could do is I could count them. Find comma in selected text only. How many? Okay, so we have 71 numbers in there. 71 is bigger than I need, so we're good. So now what I can do is I can take this and copy it entirely. This makes room for if I wanted to make a 7 by 7 matrix, right? And then paste it in here. And then also paste it in here. Save, hit save. Now let's run this again and see what it does this time. So if you remember, when I had it too small, everything was all scrunched up in the beginning. And then when I had it be 9999, all of the dimensions were so completely huge it was unbearable. Now we're seeing some really interesting results. See the tinges of blue in there? See, the hope with this, see how we've got 7 updates? We've only got 6 of these like high score settings. What it's supposed to be able to do, and it'll be very interesting to find out if this bears fruit, is rather than just generating an entirely random new one each time, what we're doing is we are drawing from 6 previous successful reverbs, and we're recombining them. So each new reverb is to some extent bred from an orgy of other reverbs being combined. We're just randomly drawing what you could call DNA from the relevant positions. What that means is if having like a really low number in positions 3 through 5 is genetically useful, that will predominate. If the fitness function is determined to go and do a particular thing, well, it'll be more likely to succeed if that thing is happening, at which point that behavior becomes represented in every one of these spots. Like, if all good reverbs had to have a number 7 in the very beginning, like slot 0, every one of these successful results would have slot 0 in that slot. And then like roughly 0.38 of the time, what it would do is try another random number of some kind. Could be anything. It would just try something random and go from there. If it's not, it is selecting among one of these previously successful ones. And what's going to happen is it's going to start getting towards... So what's going on here is we're still trying very random possibilities, but it's leaning harder and harder towards what works as I previously defined it. So if I defined it as no bright samples, see those blue lines in there? No bright samples, please, none of those. Then it would be weighted heavier and heavier in the direction of only stuff that succeeds with that. The weighting I've got in this is very complicated. It's what ended up sounding best. The longer I run this, the harder it works to try to find a most recent successful result. As soon as it does, and see we've done 9 updates so far in the few seconds since I started running it. It's still running pretty fast too. See, we're at 100,000 tries already. Let me throw another log on my fire while I'm at it, while we let this run. maybe we'll get to update 10.
I'd like to sort of monitor what that output looks like as we go. Very interested in what that does. Because this might be a bigger breakthrough than what I did before. And you were hearing all of the previous reverbs. You were hearing that they basically sounded fine. Arguably good. But if really leaning on the genetic algorithm helps, then this is going to be potentially a big jump in quality. And the genetic algorithm works better when you're doing large numbers of trials. The work that I've done porting this to C# is exactly what's needed to make it run large numbers of trials. So it should be very interesting. I'm looking forward to running this overnight and seeing where it takes me. Meanwhile, it looks like this is going.
Well, I mean, I was already using this. Like, this is something that I was already using. It's a question of when generating a purely random number and applying it to these figures so that it's almost always just, yeah, this is the random number, but if it happened to be like lower than 7, it would deign to lean on the genetic algorithm. So that was pretty much all mutation before. And now we're using the golden ratio because Airwindows world, we love the golden ratio, just arbitrarily choosing it for stuff. Most of the time we are trying to recombine. Most of the time we are trying, one of the things in this book, the Artificial Life book, there was a guy, we got another update. And you know what? And another update. The results we're seeing are looking better and better. They're looking kind of wild. They're looking kind of weird. But who's to say whether that actually sounds amazing? In a weird way, I'm pretty sure what we're doing is more accurately tracking what I've told it to seek. Because I'm pretty sure my settings are trying to have brighter echoes happening up front, and you can see that it's dense and bright up front, and then darker echoes in the reverb tail, and that's literally what we're seeing there. So we could be looking at the genetic algorithm really kicking in a way that I hadn't even expected. And we're in yet another update, and we're barely getting to 200,000 there. It's been like mere seconds since I started running. Can I try one? Maybe. Let's leave this going. And let's see, it's one of the 6x6s. Yeah, I mean, I've got the system available for doing. It'll be exciting, I'll tell you that. Sure, let's set that up. Maybe I won't even move the computers around. After all, if I'm only trying one. However, if I do that, I do want to let it run a little longer. After all, I don't know if it's still... Well, no, I do know that it's not using all of those initial... It's not using those initial numbers, and I can tell you why, because we don't have an immediate batch of echoes in there. So the idea with running a proper genetic algorithm, and this is the thing I was going to tell you out of this book, there was a guy running a sort of simulation, and the simulation was about making his little virtual organisms in the computer world that he was starting with. And they were supposed to do things like solve problems or something like that. Yeah, this is crazy. Look at that. We have intense brightness up front, which I have told that it was supposed to do, and then intense darkness and decay towards the end. If this smooths out, we might be looking at a very reasonable end result. It's not smoothing out as far as putting brightness up front, though. I've never seen it do anything that striking. Never in my entire life have I seen this program produce wild, crazy results like that. Go figure. I must have told it really loudly, yeah, have brightness up front and not at the end. Because boy, is it working to deliver that. It'll be interesting. This is also the kind of thing that I would do for, say, work out how different the side-to-side stuff is relative to center content and produce hyperwide reverbs. I would simply have to put in a fitness function where it was looking for, let's not have the sides match perfectly. Keep track of, like, are the results different, or is the RMS different from side to side? Although one of the things that you can get when you do that is you can have a very ping-pongy effect. I mean, you could just code the reverb as mid-side too. What I'm talking about is coming up with something where if you had a mono input signal, you would be getting a very stereo output even before regeneration. It's clearly possible. That or lean so heavily. One of the things I think I'm also starting to see is I think it's leaning very heavily on the primes, the outputs. So what we're seeing is relatively small numbers with a few really large numbers. Because what we see at the very end is some paths through the reverb matrix are leading to this very delayed number. So certain paths are holy crud. Holy mother of what the heck. You see the colors coming off of that? It's leaning really, really hard on putting bright sound up front. That blue there measures whether there's a lot of difference between adjacent samples, which is what will create high frequency results. And it's leaning incredibly hard on that and seems to have very strong opinion. Always bright up front, always bright up front. This is fascinating. Also, every time we do get a successful one, everything else gets easier for it. It is literally evolving using the genetic algorithm towards a better result. And yeah, like, I would be running this program overnight so that it had like 30 million trials. I've never seen it produce anything like this, but all the same, I would be running this overnight to produce 30 million trials. Let's get some of this stuff ready. You asked me to make this into an audible reverb. That is something that can be done. We'll quit out of there for the moment and get ready to do our work here. Here's where I'm going to paste it in. Meanwhile, the wood stove is going pretty good, so that's cool. Yeah. You know, live stream days are always kind of funny. I would never have guessed that I would end up taking this day to experiment wildly with the reverb. Not that I'm not, I mean, I'm doing that. I've been doing that. But, yeah, if this gives me a spectacularly awesome sounding reverb just out of nowhere, knowing that I would be running it, let's see, 400,000, I'd be running it 100 times longer times 14 overnight to actually generate a real run. And if it's able to get as good as wherever it's at now, I think that we've got some early reflections going on in there which are not going to be helpful, but go figure. Because, and I mean, who's to say? If I can produce reverb visualization, the reverb visualization is going to some extent tell me what it sounds like. Like if it's all spotty and patchy, it's going to sound kind of weird and patchy. I don't know what to make of the clear trend towards extremely bright up front, although that's not, I mean, I've been telling them to do that, they just haven't been listening. I do know that the sparser part towards the end means that we're going to be getting more of it might be a platier sounding thing, which I didn't tell it to. This is just as optimal as I can get it. I'm basically going for that density quality. But yeah, 15 iterations. So the high scores are now getting fairly well weighted in that like even copper tier is not all that terrible. Sean verbs are probably, calling it typical doesn't seem fair. The Valhalla verbs will be, I mean, combs and all passes are delays. So it's like delay, yes, automatically, of course. And pre-delay is always just a single delay. Mine isn't, but normally pre-delays are just a single delay going into it. And combs and all passes are fundamental building blocks of reverbs, except for that I'm only using combs and I don't use all passes because I'm doing that on purpose. But I see no reason why Sean wouldn't also be using all passes. Some of mine use all passes. Some of mine, like Cream Coat. Cream Coat's a great example of one that is specifically just all made up out of all passes. Pre-delays they are completely normal. So what Sean would be doing, if I'm not mistaken, is coming up with interesting combinations of things, because the way these traditionally work, right? I'm just using bog standard householder organizations, except for the very first Galactic is actually a 4x3 matrix, believe it or not. It's not even a full 4x4. I have no idea why it came out as good as it did. Lucked out. I'm honestly, I couldn't tell you off the top of my head what the difference is between a householder and a Hadamard matrix is. FFT stuff, I doubt he's using that. I don't think that's what you'd use if you were doing a convolution reverb and wanted to do a really enormous delay time. Is you'd be compelled to do that because you wouldn't be able to do it I'm looking for the word. You cannot do a giant convolution reverb with just naive convolution. You have to start using things like FFTs, at which point you're basically MP3ing the reverb results, and I don't like it. But Sean wouldn't be doing that. It's the difference between a convolution and an algorithmic. Algorithmic reverbs are much like those very earliest reverbs that people made back in the lexicon days, when the actual delay times are not that great. And they're using things like matrices, but they're mostly doing stuff like, okay, and then let's put this all pass in the feedback to this path, which then goes to these other two comb filters over here, which do this and that and the other thing, and they were combining all kinds of wild stuff. You can do really wild things. My stuff with these is entirely about trying to exploit what is initially a very simple householder matrix that's just big enough and dense enough that it can produce just about anything, and come up with the magical data to put into it by this genetic algorithm business. Yes, there can be spectral reverbs, absolutely. That is 100% something that somebody could do. I choose not to do it because I don't like spectral compression either. I am all algorithmic all the time. Preferably run at high sample rates, except for that I have everything is undersampled using Bezier curves. Yeah, so we're up to update 15. Basically, as soon as I hit stop, I will be copying out whatever we're looking at. I should bring out the laptop, is what I should do. If we're going to be using that for this. And if I do the fireplace cam, then moving around the stuff on my desk is still apparently deafening, but it's not quite as deafening as doing that with this close-up mic here. Perhaps we will take it to a even million tries and run with that. I think it's fascinating what we're looking at here. The look of this is very different than anything I've previously had, and I love that for it. Even if it ends up sounding horrible, I love the fact that this is converging on some strange new beast of reverb, which if I define the fitness functions correctly, if it is producing a nasty, unpleasant sound, I'll be able to work around that. I just have to run it for longer. But I'm loving that this is producing a weird, striking, characteristic looking sound with many of the same qualities that were desirable before. It suggests that it's going to give me something distinct. Yeah, 1 million tries. Mwah. And then maybe we can play with the video game a little. Oh, well, Visa, people do. I mean, Paul Stretch. Paul Stretch is cool. I've even done stuff with it occasionally. Not put out anything with it, mind you, but Paul Stretch is cool because it's literally doing that kind of thing and then just like, yeah, keep firing this thing for the next 5 minutes because we've stretched everything 6 million times. It turns stuff into continuous soundscapes, and it does sound very much like reverb. I do keep wondering whether it's possible to take something like that, like your MP3 or your Paul Stretch or your FFT kind of thing, and be able to reconstruct stuff better than people currently do, because everybody working in these fields, everybody working in like MP3 and AAC, and most especially like Og Vorbis or whatever, they all believe you can't hear a damn thing. They all believe you don't have to pay any attention to anything at a position under like 95 dB or so. They are stark believers in nobody ever can hear any subtleties, and so they don't make any effort to optimize them whatsoever, because why would they? They're that sure that lossy compression means it sounds exactly the same. And in the real world, or the musical world, we can tell the difference quite easily. But the people who know better aren't working in that stuff, so it doesn't get better. In theory, you could make a MP3 decoder that sounded cool. In theory, I could make an MP3 decoder that sounded cool. Do something like, okay, so we're reassembling all of this stuff. They're normally using floats and doing not a damn thing to deal with any of it. Let's instead make everything be long doubles, and then we'll dither to the floating point bus. Let's see what we get. And you'd probably get, it wouldn't sound like the original thing, but I could probably make something with better tone. It'd be a bit of a stretch, but I'd probably be able to make something with better tone. So I don't know, maybe that should be this year's goal, right? Like make an MP3 player that sounds better for people, to the extent that that even matters. I mean, it could, like, AAC is YouTube, and I listen to a lot of stuff off of YouTube. Yeah, I'm making fun with the long doubles. I honestly get by with just doubles pretty much all of the time. Occasionally, if I'm doing something where I'm like, okay, this is extra fancy, let's just use this a tiny little bit, but to sum together the final pieces that we were working on. And so I'll use long doubles as a summing. And then having done that, I'll dither to the double on VST and double dither to the 32-bit floating point for Macs and Core Audio. Yeah, no, I don't routinely go around using long doubles anymore. Back in the day, I used to. There was a time when I did. I stopped because I did a test. I did a test where I took an entire mix that was it was an Airwindows mix, so it was just all of my own stuff, but included lots of different kinds of processing and reverbs and stuff. So it had distant far field sound, and I recoded all of the plugins, which initially that was during the time that I was doing long doubles for everything. So all of the stuff, for the most part, I think some of the calculating stuff wasn't, but I was just leaning into it very hard, and all of the stuff was being made out of long doubles. And so I went through and replaced all the long doubles with just doubles, but didn't change anything else. And I replaced all the plugins that were altered in that way. And then I made another pass without changing anything in Logic, because at the time I was using Logic. And then I went and I made all the doubles floats, so that everything everywhere in the entire program was a float rather than a double. And I exported those plugins, which is like industry standard normal, by the way. And I loaded them up into Logic, and I did another pass of my piece of music like that. And what I found was the one where everything was just floats. And this is all, I mean, none of this was even in Reaper, so I wasn't even able to work with the double precision bus. But even before having a double precision bus, even when the bus for the DAW was itself float, using internal doubles for everything, in particular like reverbs, was giving me like a slightly richer tone, slightly more depth, slightly less plastic than the one where everything was floats. And it was not obvious. It was not obvious. I had examples of that up on SoundCloud for the longest time. But I had done that, and there was this slight qualitative difference. It wasn't what you'd call obvious in the slightest, but it did give something of a, using just the floats, made everything a little bit more 2D, a little bit more plastic, a little bit more, it just sounded like a DAW. It sounded like, oh, I made this in Fruity Loops. And the double precision one was more like what I was after. And then I also had the long double, and it didn't sound any different from the double. And so when I heard that, I was like, okay, never mind. Doubles for me. It is clearly enough. And every now and then I will throw long doubles into something like the processing bus for mastering. For instance, my mastering plugins go for a long double processing bus because I'm like, well, we're calling this mastering, might as well. Well, bear in mind that how these guys work, the way that they process stuff tends to be a little bit daunting for me. I have trouble with how they go about doing their things. It's typically like programmer style clean code and functional code, and so everything is very abstracted, and I don't really think of things in that way. So when I do code, like you see in my C# code here, it's all very sequential. It's almost like assembly language with delusions of grandeur. Meanwhile, we're moving along pretty much. This might be the apex of... It would be extremely funny if we get one more update just before we're ready to go and it ruins everything and makes it be bad. But technically, that shouldn't be possible. We've had 15 updates getting up to this point. I bet you we're not going to have a lot of those original values in all of these, or that sequence of primes. And there will still be a sequence of primes, but we'll never see them because we're only working with as many of these as we need. There's something to be said for if music is too loudinated, you stop being able to tell the difference, yes. Although it will still help. Like, if you have a lossless format and you're in a higher sample rate, even with loudinated stuff, there should still be a character difference going on. Like whether it's better than... Because that's also another thing. There's a whole other thing about that. And I really should be doing this. Putting up examples of some of the classic music out there that you can't put on YouTube using my Content ID plugin, so that you can't actually hear what it's doing, although you kind of do a little bit, but you can see how it shows up in meter, because here's the thing. A bunch of that classic stuff like Beatles or whatever, that's heavily loudinated compared to what actually accurately capturing the sounds would be. Actually accurately capturing the sounds is more like what you get out of mid-70s. The stuff that was, the magic of the 60s and all of the Beatles and all of that kind of stuff is very similar in many ways, but it is typically saturating and overdriving all the peaks away, which is exactly the same as loudinating, except for that it's distributed. It's across the entire system. If I end up going and making something like, oh, hey, here's the EMI Red Airwindows version. It's the one that's the old tube console, and you only have 4 tracks. Here you go. Here's the EMI Red. Here's the Beatles console. You want the Beatles console, right? All I would be doing is just saturating everything like hell. I'd be doing a lot of other things to make it be actually good, mind you. But to get that sound, you're just doing a bunch of overdriving. All of the RMS versus peak is really hot for that stuff. That old stuff, man. So, with regard to those things, yeah, loudinating is part of the sound for a bunch of things. And it's not exclusively like heavy deathcore metal music. Your classic Beatlesy 60s rock whatever that is so clearly distinguished from what people get out of just sitting down with the DAW and doing their best, that's just the sound of overload. That's just the sound of tube distortion. The Red console is a tube console. EMG's TG12345, that's the first transistor console they had. And that's the change in sound between all their earlier stuff and Abbey Road, is the sound between tube and transistor. And all of their earliest stuff, no matter what it is variations on tube overdrive. Just like if they had a bunch of little guitar amps in there. And hey, looky here, we are almost to the point of hitting stop and going with whatever we've got here. 8. Watch it update at the last moment. It's not going to though. Boom. We'll take it. Update number 15 is going to be the one. Boop. And we paste it in. And here's what we had. So it looks like 5, 7, and 11 actually stayed. So did 13. So did 17. A bunch of these primes actually stayed, but then it swapped out a bunch of other ones. We got a 214 in there. We've got another 17, but that's a duplicate of this 17, so that's quite interesting. These might be native to the original ones. 67, 71, 73. It's hard to tell which of these are actually the original values. It's like it's optimized to make as much as it could out of all these original values. So there's ways I can work around this, but it might not be necessary. Let's see what this was. Hit save, quit out of here. Eject it. So I don't have this screen showing, but whatever. It's not going to take me terribly long to do. I'm very curious as to what this is going to give me. Also, I could very likely, if I picked a larger, here, let's set up another round of this. We've got another couple of hours of streaming, and if I don't start playing the video game, I won't be still coding until 9. So there's that. If we simply run this once more, but this time we tell it to do a much larger reverb. See, a 2,000 seater. Let's in honor of Prince, we call it 1999. And then if I hit 6x6 again, it's going to start trying to generate more. But see, the deal with this is it can't be using the original values. They're too small. It has to start coming up with larger values. So let this run for a while. It'll probably replace more of those initial values. And that is what I'd like to see. So meanwhile, while I'm doing that, and we'll see what that sounds like when that one gets to 1 million samples. I'm going to fire up verbs text and straight up copy this only example out. This is the mostly just the primes example, but it substituted a bunch of these in. So many of these have actually been changed, and it's using the genetic algorithm to figure out which of them get to change and which of them stay the same. I'll paste it in. Copy the file name. Build the new reverb. Replace it. I do this multiple times every day. Beginning of each day is 14 times of doing this. Oh, look at it coming up with more updates for the larger one, which stands to reason. Like, of course it's doing that. Question is it going to be useful? Then launch short for echo. And I'm going to play it off of the laptop before bringing it over to the main one and playing it directly to stream. Here's the new one. It looks fairly normal. There's the genetic one. It sounds basically normal. Fascinating. So there's a bunch of things still wrong with it, but I tell you, then paste in its file name. We're saving it to the SD card. I'm going to bring it back over here and you can hear it directly. Wasn't that long of a loop through doing this. I'm also very curious as to how it performs with my evaluation techniques. I'm going to put it through that process. Here we are. So watch how this is the end of the stream, as we just keep doing this. And if we are only running one of these, why, I can probably do a batch process on the SD card without too much trouble. So we need to run pre-normalize. Just going to overwrite that file by normalizing it to full volume. And then I will run the evaluation script, which will give me a little spreadsheet with only one entry in it. And there we go. So there's our spreadsheet. This is also what I do every day. I can delete those columns. Okay. And so the end result is it is already scoring quite high. I color code that as red. That is what I would call a success. First try. First try, and it already came out the way I was looking. And how does it sound? Kind of like this. Here we are. That's a small room. People are asking me for small rooms. Looks like we get small rooms out of this. That's a small room. That's completely convincing. Some of it might be you're hearing the DI and also my speakers at the same time. So there's that. Here, tell you what. I will shut off my speakers for the moment. And now you will get to hear what it really sounds like without any interference from my speakers, because that would be producing some ringy sound. Now I can't hear it. Oh, I'll leave it playing. You can hear it properly on the guitar now. Little pause. Yeah, I mean, the thing is that we ran that for like fairly few minutes. It should be possible to keep it going for long enough that it works its way through the ringiness. Some of that ringiness is almost certainly the result of just using the initial values in the arrays. We've got a whole bunch of arrays, and they are all just sequential primes, which has nothing to do with what we're actually... If we just took that directly, it would sound appalling. We're not. Instead, we are optimizing it. But the amount that we're optimizing it is surprisingly little. So yeah, I guess the next question is, like, now that we're trying to make an enormous sized reverb, and we've made 1,000-seater, then what can we start seeing more updates out of this? Because like we're sort of doing all this while you wait. It's like I feel like I could be randomizing this more. Because when you have a bunch of really small delay values in there, it's gonna tend to produce stuff like the bright stuff that happens early on in here. And it has having some good qualities, but at the same time, I can't help but feel like it's possible to optimize this better. Oh, what you were hearing? What you were hearing was literally all and only wet. It was the raw output of the reverb without even like refinement, like without even... It was all wet, plus only using one setting for the position. And then this one, we're basically trying to see if it updates again. It's got enough going on that there are some distinctions in there, and will have been through various updates at least some of the time. But a bunch of it is still sneaking through. I really do wonder whether there's a way that I can randomize this better. Although in a sense, I'm also just as happy to, and considering, like, this is something wild too. Consider what this means. We generate something like this. We produce something which is like pretty good for a not many iterations genetic algorithm. Nothing I've done previously would be able to produce that off of that little time. Like we're coming up to about 250,000 tries on this. That's not nearly enough for just randomizing stuff and testing it. But instead we're starting with a relatively unhelpful just list of primes. Just start into those. And then every step of the way, if we get a successful reverb that's better than the previous one we tried, what it does is it swaps that successful one in, replacing that entire array, and moves all the arrays down one. And every single time we're doing a new try here, like 0.618 of the time, it's drawing from the previous examples, one of the previous examples. And then 0.38 of the time, it's trying a completely random number. But that applies to every single one of these. So essentially, when these initial settings stick around, like when it's like, okay, it started out as 31 and it's still 31 a million trials later, what that means is it tried a million times to try to construct one where like 0.38 of a million, it was putting up a different option, and the different option did not succeed. The idea is to keep running it so that eventually it hits upon something that is more successful. I would say it's masking it a little bit. The fact that we get to try these random numbers, and if you combine like a 37 with a 71 with an 89, by leaving those still what it started out as, then it's fairly likely, since those are primes, if you include them, your chances are higher that using those in the end result is going to produce something that's basically okay. But it's still wild to me how long those initial values stick around sometimes. And I don't really have a good way of initiating them differently. Although I most definitely have ways of scrambling them a little bit more, and that might be worth me checking out. How about we hit the brakes and try an experiment? Are we good with that? Because you see, the way this draws on the initial values, we can at least randomize what it ends up in such a way that it'll shuffle more aggressively, rather than being stuck with just one possible value for all of one position. We could adjust it so that it's like adjacent values, if that makes any sense. Oh, looky there. It found one that was better. So when I say adjacent values, here's what I have in mind. I'm thinking of taking this like private int gold, private int silver, blah, 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 etc., 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 where it's very frequently resorting to, let's pick one of the previous successful ones. Now, if we ran it for a gazillion years, and there were sections that were always basically the same, and those just performed so well that we stuck with them, and so that slot in the arrays always ends up being a particular thing, then that will become predominant. What we're looking at is a situation where, look to the side of the thing. You got like 53, 59, 61, 67. Now it's going to randomly select among those. It's done that like 330,000 times at this stage. But every time it's hitting a previously existing one, if it's going to that 61 slot, it's going to hit 61. There's some randomization, but that's not producing actual differences. What I can do is drag this into the text editor, select a big chunk of the list of comma-separated values here, cut it, and then paste it in at the end with a different offset each time, so that they all initially have my list of prime numbers. We're starting with numbers that are potentially okay. But if it's a different offset each time, what that's going to do is when we go to a slot, there's going to be 6 different possible primes that it can draw from rather than just one. And that will force it to be different. That will force it to be more different more often. And then we'll get to see what happens there. So I think that's worth trying. So perhaps let's go and listen to what this monstrosity is, even though it's almost certainly what I see there in terms of the alternating light and dark bars is this is going to be one of those echoey ones. It's had many chances to come up with something better, but we've only ran it for a few minutes, so honestly that's not that important. we're going to run with it. Boop. Let's quickly go and see what this one sounded like. And looky there. Second, third, fourth, fifth, sixth, seventh slots are all literally what they were when it started. I could be randomizing that a lot more. It's doing random selections from earlier ones. It doesn't have to be all exactly the same. I can have it be random, attempting randomness a lot better than that. But for now, we're going to see what this sounds like, even if it's not optimal. That is, after all, what I was asked. Grenz was asking me to do that. So, same process. I know I don't have the screen of that loaded up, and that's fine. If I'm lucky, I can go through this fairly quickly. We still can. Verbs text. Build, copy. Oh, I forgot to quit. Let's remember to do that then. New version. This larger one sounds like this. And save as. Currently saving off the antique. Quit out of twisted wave. Bring this back in here. And batch file. Normalize. I figure if I do them one at a time, it'll be able to deal fairly well. If I try to do a batch normalize on a bunch of different files off of the SD card, it just chokes because it's trying to open a bunch of files at the same time. SD cards don't like that. And this gets to just read. And let's see what we got. Okay, this one was 15.37. Color coding of that ends up being green, which is pretty respectable for that size because the color coding of it tends to shift with the scale. That's not bad for that size. And now I get to hear it again, and here's what this one sounded like. Wild how well this is doing on so little, even when the actual result is pretty... Like, this is not a good reverb. And yet, it sounds a little bit like it is a good reverb. crazy. That is crazy. So let's go and try to make it be even better. Here's search 6. Copy. Fire up old BBEdit. BBEdit's making the windows be extremely inconvenient, and that's fine. Tell you what, let's stretch this straight across the screen so that I can work on it more easily. So we can have the initial one be this many, and then keep offsetting them. I made a mistake there, but it wasn't a serious mistake. You can't see it anyhow, so it's fine. So then 13. So what's going to happen is if you randomly draw from a slot, but it has to be from the same slot, there should be a pretty wide variety of possible results that you get. Because as it is trying to pull from previously successful ones, what I'm doing is I'm starting them out with a much wider variety of end results. So let's see, 13 over to, say, around 29. Oh, one of the things I'm going to have to do is deal with these commas. I'll just clean it up as I go. It'll be fine. There we go, remove the space here. So let's go even beyond that this time. How about over 2, 13, 31, how about 47? Just jump way over. This is all super arbitrary, but it should be just fine. The only thing I'm careful about is not ending up with weird extraneous values that aren't going to be helpful. Oh, I'm very curious to see what I'm going to get when I run these longer too. I just feel like I've got to randomize some of the initial stuff more. I'm okay with using these primes here, but I want to offset it so that it just shakes things up more than it does initially. Because it's hanging on to so many of these. Every time it comes up with like the same value at the end of all of that, it could have been trying from an array of values from all these previous ones, which is what it keeps looking for. It could have been swapping out, like, let me continue this and then I'll tell you. Where are we at? 53, eh? So instead of 53, we go to like 71. There's a 71. And then 89. Because why not? See, we're offsetting every step of the way. It's probably going to end up with just the numbers getting bigger as we go. But what this means is this time, if we're trying to randomly select from some previous one in slot 0, well, maybe, well, I don't know why I've got 2 here either. Let's cut that back. I think it was forcing it to, we're going to remove the 2's, okay? We've got enough slots here to work with. So rather than every possible earlier example giving you a 3, meaning that it keeps trying stuff, but every time it's going on the previous ones, it has to pull 3. This time, at least that randomizes. So maybe sometimes it's 3, maybe sometimes it's 13, maybe sometimes it's 31, maybe sometimes it's 53, sometimes it's 71, sometimes it's 89. And the thing is, if 3 ends up being the ideal space for that particular slot, the successful ones will all start ending up being 3, and it will predominate over the other possible random values. Let's see what we just got. This should, theoretically, be a big help. Can but try. Boop. And the same is going to apply for here. Hit save. And so do you want a really long one or a shorter one? We're going to try another one as we wait, which is now newly randomized. So do you want another big one or do you want a tiny one? Because it should be able to more quickly arrive at whatever we're aiming at. So give me a request. First person to say short or long, or a number. Like the end seat size is going to be about 1/3 to 1/2, or maybe a little more. Let's call it the end seat size is going to be the golden ratio of what I specify. So give me a desired hall size number. Number of seats in the room. 69420 doesn't count. Tiny, eh? How many chairs fit in this room if you fill the room with chairs? I will multiply that by my target number and produce a result. How many people can sit in this room comfortably? Ooh, we got two opposite. Well, we'll see. We can do both. Oh. Hey, give me a number. How many seats in the hall? If it's a Titanic number, it might act a little weird. 200. Okay. So 200 means we're probably targeting about 500 or so. What I'm going to do is I'm going to dial it. Oh, fine. 200 is actually going to call for something like this. So we're going to go with 420. That should produce roughly 200 seat rooms once it sorts its stuff out. And look at that. We've already got a somewhat more even distribution than we had before. And that's on only 8 updates so far. Interesting. Also, I'm about 20 minutes away from thawing out my taco food. But, yeah, I am. Oh, no, we're not doing numbers anymore. We're settling on one that ends up being about 200 seats. It might not look like it's doing it right now, but it's going to try. Generally, if I specify a number, the results I end up getting are smaller than that by some amount. Actually, they end up being about a golden ratio smaller. Isn't 3,000 seats kind of a big room for a dance club? Isn't that kind of a big place? I mean, we could try the stadium. We're currently trying the 200-seater room, which might or might not end up, they are ending up sounding smaller than they look. I'm getting like 528 seats, but the way that the end result tapers off like that is akin to having a small... The thing which is weirding me out about this... Oh, there we go. We got an update. Because every time we get an update, it's going to be drawing more from successful results. And essentially, it's just mutating little bits here and there. Yeah, 3,000 is a pretty freaking large place. I'll tell you that. There's no question about that. Let's maybe play with the wood stove a little bit more. Not that it's really cold, but it looks like it's a fine opportunity. Seeing as we're running this test file, it's a fine opportunity for throwing another log on. This is quite nice having you all here for doing this experiment, because I did not expect that to work as well as it did, which is very normal for genetic algorithm stuff. I'm given to understand that's pretty much usually how that goes. If you really truly unleash the genetic algorithm properly, what you end up doing is producing wildly more effective stuff than you thought. Honestly, see it's starting to come with smaller room sizes. That's probably half decent sounding already. Although I'd like to run more tries on it, but that's probably half decent sounding. So one of the things I'm considering is maybe what would make this be more good is make yet another ranked high score. See where it goes. Gold, silver, bronze, steel, brass, copper. The names don't mean anything. It's just like, okay, so in order of greatness, every time I succeed in making better than gold, everything drops down a rung. And that's how it's able to draw from a series. And see, here we go. There's another. That's how it's able to draw from a series of previously well-performing reverb behaviors to get closer and closer to its desired result. So logically, what it was doing, and I can probably scroll this around. There we go. So we're instantiating that like that, and then we're generating all of this stuff. This is all of the, like, getting it to do what you want, adjusting it. This little window has a bunch of other controls in it, which I'm simply not showing at the moment, and I tried to make them be optimized. But it's the same thing where I was making some things be hall sounds and other things be plate sounds and stuff. I was defining those based on how this stuff works. So like adjust shape, adjust blue, those are all different weights based on where in the decay tail it is. I can make it be darker as the decay continues. I could make it go brighter as the decay continues, and it would valiantly try to come up with a way of making that happen. And then here's all this mechanical stuff. But here is where we go through selecting among different ones. So I could add more and just have larger numbers of previous successes to draw on. That actually would make sense. I'm currently doing it so that the most recent one is twice as likely to be called upon as any of the others. But this is simply just counting. Sort of select mod 7. So it's just selecting among those. Oh, look, we had another update and now it looks much better. That's cool as hell. Wow. Looking good. That's looking real good. Like the looks of that a whole bunch. So if I made more of these, those are not part of the main crunching loop. Having more of these would not make stuff run a lot slower. But it would have a larger body of. So the idea of how this is working, rather than keeping an enormous population of like this one was good, that one was good, we're hybridizing them by crossing over at a certain point, but we're using all the same numbers from this or that or the other. What we're doing is keeping like a top 6, and just every step of the sort of DNA of it there's a large chance that it's going to draw from one of those previous 6, but there's no particular favoring of any of them. It's just like grabbing from one or the other. Oh, look, we keep updating too. Look at that go. Look at that go. And nothing's really stopping me from making lots of them. Honestly, if I had 10 of these, we would have already gotten to where the very last one would still be the sort of randomized, the random array with basically just a bunch of primes in there. You could have them all start with exactly the same values, but it's working way better to not have them all start with the same values. But I could have pretty much any number of these that I wanted. When I run it overnight, we wind up getting into 20 or 30 or more of the updates. Every one of those updates moves everything down a slot, meaning that the successful ones that we're drawing genetically from are more and more seeded with successful algorithms with good DNA, which are producing the desirable results. So if having these actually be prime numbers is disadvantageous, what would happen is they'd quickly start getting replaced all the time, and then the ones that replace them would never have prime numbers in any of these slots. So they'd all get replaced by, or if the slots were all 12, and then it was very disadvantageous, you'd wind up with them getting updated a lot, and the 12s would just start dropping away. It's just that it's taking too long to get there. So I'm looking to do it in this other way. So what I'm wondering is, can I work on it? Or maybe let me know if you want to. I'm not sure you can respond fast enough. Let me know if you want to hear any of these as we go. Honestly, I feel like this is coming along pretty nicely. I like the look of this. It's kind of doing way better than I expected. Like the first time we got a pretty decent result by taking it to 1 million. Second time I was talking about trying other things, and so we didn't even go nearly that far. And it still sounded half decent. And this one's looking even better. Although the early brightness kind of went away very quickly, didn't it? That's fascinating. It's not leaning on that as hard as it was. Although the overall density, the overall distribution is really kind of similar. Yeah, so essentially if I had 20 of these slots, which I'm currently just coding with names of precious metals, so gold, silver, bronze, steel, brass, copper, tin, shite, increasingly worse ones, and you don't update that much, then the worst one ends up still being seeded with all of the initial values that are I'm rating the quality in a number of different ways. So what it's doing is it's algorithmically going through and comparing all of these to the fitness functions. So the fitness functions are doing the lion's share of the work. It's trying to make sure that none of the, look at there, we've got another really bright early on. And then immediately another update, okay. So what could be happening here, this is almost akin to the way that genetic algorithms naturally work. So what happens? Metallic is bad, but I have no way of defining what metallic is. I really don't know how to define what metallic means in a sequence of delay returns. I mean, would you? I would assume that having the same number showing up would be bad, except for that doesn't tend to be what ends up happening. I would assume that having regular echoes or a series of echoes would be more metallic, and yet that doesn't seem to be how it works out. So I don't know how to define what metallic is. What I've been able to do is I can track the greenness of it, which is how many times the echoes are stacking on top of each other. And I can go, if it's stacked on top of it too many times, that's bad. It needs to not have all the echoes land in the same place. I can check to see whether, like, is there an echo and then a silence and immediately another echo? Because that translates into the blue color that you see, which is big differences between adjacent samples rather than a pretty even distribution of samples. I can check to see whether the spacings between the samples towards the end or up at the beginning are always the same space between samples, which would probably be like metallic, or whether the spacings between samples are always different spacings between samples, which would probably be more natural. And the more I've built these things into the fitness functions, the better it has ended up sounding. So it's been this long, slow process of evolving the fitness functions, still while having it mostly start out as basically randomness. So this is a breakthrough day. This has indeed been a breakthrough day. But the fitness functions have been progressing this entire time. And then, like, if I'm getting a lot of situations where, see where it says 2 to 119 milliseconds? That is the time delay of the soonest reflection compared to the time delay of the very latest one, because it'll track both of those. So if I have one where all the delays are roughly the same length, or where all of the pass through the reverb always have about the same amount of delay, that will lead to a situation where the first number for the first delay that you hit is much later. When I do that, what happens is you initiate the sound, and then there's a pause, and then a much denser reverb hit. Which means that if you're doing that, and you're cross-feeding the left into the right and back again, you wind up with a ping-pong effect. You wind up with, like, left, right, left, right, left, right, the kind of thing going on. And I don't like that, so what I did was I told the program, like, hey, initial delay sign, this 2 there, like, the quality function has, like, plus 1,000 divided by what that initial thing was. Meaning that if you have really, or the opposite, meaning that if you have a really long initial delay before any initial sound, it's going to start rating it worse. It's adding that to the overall calculation. And so that's basically how that stuff rolls. It's like, if I can identify the way something sounds in the behavior of the echoes, I can code around it. And the way the genetic algorithm works is I can have all of those parameters happening at the same time, and basically demand that it does all of the things at once. It has to do the green business correctly. It has to produce more primes in the final output, the combined result. It has to avoid placing silences against multiple loud results in such a way that it would cause brightness, especially towards the end of the tail, which is what I've told it to do. I've told it to avoid brightness towards the end of the tail, and it's doing it. I can tell it to have like different spacings between gaps when there's spacings in there, and that's what the little red stuff up at the very top does. And I tell it to do all of these things at once. And it doesn't know how to do all those things at once, but the genetic algorithm figures it out. Because the genetic algorithm goes like, okay, how good can we do? So what you end up getting, and I'm seeing some of this, is you run it, and it goes through a lot of randomization, a lot of speculation and interesting trials But what's going to happen, and this is going to happen also when I run it overnight, is as it starts filling up the range of possible things it can draw from for the genetic part of it, as it fills those up with successful things, you wind up getting to plateaus where the performance gets to a certain point, and then it doesn't tend to get any better. Like, for instance, if every single successful reverb had to start with the delay value of 2, then no matter what you tried, like you'd try a delay value of 17 or whatever, and none of those would be any good. But as soon as something hit that delay value of 2, if that was what made it be good, you would have a higher score. And so your gold entry for that place, hey presto, that becomes 2. So it's slightly more likely to call upon it. And then you hit another one that's successful, and it also has 2s. Now gold and silver both have 2 in that spot because it's the successful thing to do. And then you keep going, gold and silver and bronze all have 2 in that magic spot where it needs to have a 2. That makes it more likely to try other options where it'll make it more likely to try the 2 in that spot. Now, I don't know whether it's looking for 2s in any particular way, but this is also going to simultaneously find like weird correlations in things. Like if it goes, hey, the diagonals of this householder matrix have to have this particular quality. You didn't know that, but guess what? The diagonals of the householder matrix have to have this weird quality where they have this particular mathematical relationship. Did you know that? And I wouldn't know that. But the results that had that would start winning more and more, to the point where they'd be filling up the entire space. We're up to update of 15. I've seen like updates of 30, 40, 50 after a long night of running this thing. And that would mean all of the genetic population in that instance of the program would be full of the correct answers. So you get into a situation where if it starts to hit upon something, no matter what it is, I don't have to understand what it's hitting upon. I may never understand what it's hitting upon. But if there's something out there to find, it will find it. And asking an LLM, asking like a modern day AI to do this will absolutely fail. Unless you have the AI write a program that does this. But I've already written one, so why would you need to do that? It's quite something. It's very interesting. I'm loving how sort of weird and muddled, and I feel like this is going to end up. We'll listen to my results as I go. It feels like with these looking more just weird and chaotic than the previous ones I've done, no matter how many, like the previous ones that I've done, I feel like this is going to give rise to more distinct and individual sounding reverbs. It really feels to me like I'm going to get distinctive sounding stuff out of this. And some of it might end up sounding metallic. After all, everything is being done with comb filters. There are no all-pass filters in this at all. So there's no blurring of it at all. It's doing everything with just raw reverb returns. But they should be more distinctive sounding than you get off of just making the most featureless reverb tail that you can. This is the opposite of that. Rather than being the featureless reverb tail, this generates like realistic densities of echo returns for weird spaces. And with a bit of luck, I can get some weird spaces out of it. So shall we try this one now? It's actually returning a larger theater size than the one that I filled in. I was asked for a 200-seater. It might actually end up sounding like a 200-seater, though. Because I feel like the next thing I'd like to do is bump up the number of population entries quite a bit. I'll go from 6 to like 10. It should be pretty straightforward. And that'll be a fun thing to do. Oh, however, it says it is 3:57 p.m. So I'm going to run this just a little bit longer because I'm going to go and thaw out my cheese for making tacos, and I'm going to turn on my stove. And I'm unlike when I'm working on the video, I don't know what it is about the video games that I can't like step away from them. Maybe that just says that the video game is going to be good. I'm going to keep this running, and I'm going to go and get my dinner ready. And we're only going to go for another hour, but I will have this. I'll show you several of the results of these. We'll do the change. I'll run another one, come up with another room size that you'd like. We'll give it a try, and you'll be able to hear the sound of the new reverbs all the way to the end of stream. For now, off to turn my stove on. Alrighty, did it update? I don't think it did. We'll take this. Here's where we gather our information together. These are the previous two that we tried. This is going to be another small one. I'm fascinated to see whether it ends up being like a really high scoring one by how these things work. Hit stop. Paste, here's the new one. Oh, look at that. Okay, so it did end up being quite a small size. Also, this is weirding me out that it's distributing the 3x3 that way. I didn't think that was going to happen. Well, one thing at a time. Let's look at our numbers. It's favoring primes still, but they're randomly selected. No question about that. And then D6F is not a prime. Seems to be, yep, we're doing a bunch of different things. We're doing certain numbers of large ones and a lot of smaller ones. There's a 10 in there. I wonder if this is going to be doing the duplicating of values that the other ones did. Like, if that actually helps, it will end up doing it. It looks a little bit like we don't have all that duplicating of values in here. Let's see what we've got. Little save. Bring this over to the other computer. Usually I do this 14 times in a row, so it does at least go a little faster when I'm only doing one. I'll give it that. It's kind of cumbersome but it does go a little bit faster when I'm only doing the one. Bottom of the page. Copy the room size and code. Copy the components folder. Open the audio program. Run 6 verbs, verb 6s. It's positioned in such a way that I can hit apply and close and it immediately takes it. Preview. I hear a bit of a frequency honk in there, but that's fine. We'll see what it gives us. And save as the new file name. 296 seat 1729923x6 FLAC. One of the slowest parts is actually saving as FLAC. So if I could do a thing where I could take this initial the end result there and save it in some kind of lossless way to see what kind of compressibility the end result has, that would also be useful. I'd quite like to try that. I don't know how I'd do it. I'd be wanting to call up some kind of either Godot or C# thing where I do like, okay, quickly do a zip on this. Even if it took it a while, it might be such a useful thing to add that it'd be worth it. I don't know. What I do know is we have now successfully got the audio for the new thing. And you're about to see it now. Here we go. And again, twisted wave, batch processing, batch being literally just this one, which we're using to normalize it so that they all match basically, so that I'm doing the volume comparisons and stuff on an equal basis, so they have to match. And then DFFT analyze, which is going to tack this new one onto the end of the list of the previous ones, because that's completely fine, no reason not to. And the new one, honestly I don't need to delete those columns, I'm just used to doing it, is another high score. Okay. 16.41. That registers as a red-orange in my color coding system, which is one of the highest scores we've seen yet. Dang. Okay, well, first of all, good for you. Second of all, what does that actually sound like? We're about to find out. Rolling. That sounds like there's no reverb there at all. It just sounds like the drums are there. Very interesting. And then we got guitar, and then we got alien kittens. Yeah, man, that just sounds like there's a guitar over there. Wild. Sounds like reality to me, man. Wild, wild, wild stuff. Yeah, my immediate reaction is, whoa, that sounds like the real thing. Wow. Okay, so let's make more of these. I feel like that can only help and be good if we make more of these. So we're going to do that in BB Edit. I see no reason not to just stretch out the window until there's room for me to shuffle the files around. So we'll do that. And then we just need to make up some new array names. It was meant to be a small room. I turned down the speakers so that it would play a little better for you, but I wanted to hear it too, because after all, this is my work. Yeah. I would not say so much too small of a room as it's doing the correct thing for that, but these are giving me better results in terms of not having the reverb just be an obnoxious honk. I do like that. So let's copy this over and make a bunch more of these and come up with new names for them. Tin. Lead. Mud. Poo. LLM. Okay, how many do we have now? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What, if anything, is sub LLM? Oh, Musk. Perfect. I think everybody agrees with that, right? And now I just need to update these, and we have a 12 rather than a 6 entry thing to draw from, which will get progressively filled up by successful results, but it'll also be a better randomization up front. And it'll take longer to get through, but that's probably fine. Which means it might not actually be that impressive. So 89. Let's go to 107. Be patient with me while I fuss with some of this stuff. Fair. Yeah, a lot of these things are frustrating as you start struggling with them. It's fine. Lid. So 107. Let's do 127 there. And then next one is mud. All of this is just going to be fairly quick to bring up new variations on. Shouldn't be too hard to do at this stage. Mud gets to be, rather than 127, that can go to 137 or 139. And I'm trying to avoid having these really big numbers in here. Let's see, 139 to 151. I like the idea of poo array being 151 because 151 is also famously the name of a really intense kind of booze, and I can't be drinking a really intense kind of booze because that stuff has always been very bad for me. So I will have poo start with 151. Go, ha, see, I always told you that was bad for you. LLM, what's a good number for that? 173 should be fine. And I could be keeping, I could just simply be going for larger numbers, but there's no special reason to want to do that. And then the lowest of the low, Musk, 173. Yeah, we'll just have that be 181. You can't always come up with amusing jokes for doing these things. It's fine if you don't. Some of that is strictly just for my own amusement, as you may well be able to tell. But if you look at how it sort of crosses over with the values, this is how it's supposed to be able to grab for random values and bring in a whole wide range of them, depending upon the position you're drawing from. So this actually might end up drawing smaller numbers again. One thing, if I wanted to really randomize this, I could make it so that it wraps more, so that you get closer to having the full range of between 3 and like 359 for each one. Then each of those initial ones would have the widest possible range within them. Maybe that's worth doing. I am, after all, drawing random numbers from like a vertical slot through these. So if those have the widest range, that should give it more options for trying random stuff and getting off to a good start. Question is, how important is that? So what I mean by that is, I've got it so I've got these 12 options, and the ranges they draw from start as very small, which you don't want, and extend upwards to rather large, but I could have it extend across the, sort of the full range of possible numbers for each slot. So rather than the middle being like, okay, this slot goes from 103 to 293, it could go from 103 through to 3 and then up to, I don't know, 97 or something, so that every slot would have access to a randomly selected small number or a randomly selected big number. Maybe. So what would I need to do in order to make that happen if that's what I wanted? I say that would be dragging more of these out. Well, or if I just hit a bunch of undos, I'll be putting these back to the beginning again. There. So now if I push this a little harder, so we go from these up to these. I can probably have the comma at the end, but maybe not. And now I just push way harder to get to the end of these. Or go at it from the opposite direction. So what does that mean? That means we do that and clean up the bit at the end. And then similarly, don't mind me, I'll get there. Step over to here. See, any vertical slot through these should get a wide range of possible numbers, no matter where you're starting, if I do it right. So same deal here. I got to 293 that time, so we'll go to 271. I need to put in the comma, and I need to clean up the bit at the end. Which probably I don't. Honestly, I bet the array definition would be just fine if there was a comma at the end of the final entry. I'm just assuming maybe I don't want to do that. So 271, go all the way to 251. And now we have only 10 and lead, and we have to get to 113. So select from here, 251. We'll go to 223, or even less. No, we'll go to 199. The distribution of this is not perfectly even, but it doesn't really need to be. It really doesn't need to be. Then let's see, 190 between 113 and 199 gets me to we'll call it 157. There. So I'll keep these, and now if it randomly selects from one of these slots, it'll be picking from a pretty wide possible range of numbers, whether they be initially very small or actually very large. And if it does that and fails, well, then it's going to not get anything. But it's a wider range from selecting. Whereas previously, if we only had these many, you start out at this initial slot, and it only gets to pick between like 17 and 97. And stuff like, if you went all the way over to the end, which you can't, it only gets to pick between 271 and 359. That's a restricting factor. But now, no matter where you start in a vertical slot, it can come up with some form of random number across a fairly wide range. So we're going from there, meaning I have to now paste this in, and then we start using them. And if I'm lucky, see, there we are. Lovely. I'll remember those crazy names and be able to build them in. So okay, that's the randomization. I don't want that right away. I want to do the assigning new values, and so that's how this works. That's the number of selections. I should open up BB Edit again so that I can see what my names are. Otherwise, I'll straight up forget all the time. Oh dear. Okay, that was a mistake. It's not a bad mistake. I forgot I didn't have that loaded into my paste anymore. There we are. Now that shows me what those arrays are supposed to be named. I can refer to that. Now we go down here. No, not down there. Even further. Here. So copper, brass. Copper, tin. Tin, lead, mud. They get increasingly more humiliating, these awards. Mud, poo. I think I didn't copy quite enough. I think I didn't sig to the lowest possible level. Below poo is LLM. And then there is no lower than Musk, so I didn't actually have to copy that over. Oh yeah, I remember Junebug. People who want to troll and make trouble show up now and then. We've had some recently too. Alright, let's grab these and use them as they need to be used. It's not the 6th best yet, that's more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Might as well update that while we're at it. And then down we go. All the way down to here. So I think this is the bit that I copied. Although I'll find out real fast if I didn't. Nope. I was not mistaken at all. That is actually correct. So each successful one propagates downwards over 12 rather than just 6. Not much of a loss. Here, hang on a second. I want to throw another log on the fire. As the new troll said, I'm nothing if not about the log, right? The new troll thought they would get a rise out of me by saying, I have a picture of you blowing guys. They thought that was going to horrify me. Perhaps they were a child. It's kind of ridiculous. Honest to God, even trying being gay, it was not something that floated my boat. I didn't bother with that part. It wasn't interesting. But man, to show up and think that that was going to ruin my day. Dude, grow up. That was deeply weird. So yeah, we had a troll who showed up and thought that they were going to be like, you suck dick, and it was going to destroy my brain. I was going to be like, they said the thing, Crazy people, man. So yeah, here we go. My order of good to horrible amuses me, but then, that's why I'm doing it. If you can't have a little bit of sass, there's something wrong. So here's where things get a little busier. I'm going to need to do this for both of these things. Although I do believe I can do one and then copy it to the other. It's not up there. It's down here. Here we go. Yeah, it's within this entries loop. So there it is. Again, we are selecting yeah, if random F is less than golden ratio, then we do one of these. All of this is going to be updated. All of this, the entries are iterating over the full range, but we don't actually need to worry about that because we have enough in these arrays to fit any number that we want. Did he know? Did he spend 5 days waiting to say that to me? People, man. People are crazy. 1, 3, 4, 5, and that's going to keep going. And then we are going to change this mod number to something more like 12, possibly 13. I'm not entirely sure. But this bit gets to simply loop. Or at least it will if it lets me select and paste. 6, 7, 8, 9, 10, 11, 12. I bet I don't need as many as that, but we'll find out. I don't know whether I need to update all of this. If I wanted to stay accurate, I do need to update all of that. It's just a little time consuming. Well, not all that time consuming. Oh. Okay, and now update it with the names of the things, and then I'll follow up by referring to the literal copper point of the gag is the awards are made out of increasingly bad materials. Lead. Meaning that I have one extra one of those. So now I got to update the names appropriately. If I do this right, I can copy this over to the 4x4. The arrays are not capitalized, so I can do that properly. Alrighty, now if I get the rest of this correct, it'll work. Well, you know, there's a number of reasons why I try to keep the streams neutral. You know, Mr. Rogers had a saying of, if things are bad, look for the helpers. And I think that's pretty legitimate. But you can't necessarily change people just by modeling behavior. And yeah, I've had all kinds of people showing up. They just don't necessarily hang around if they can't get a rise out of me. Typically, they don't really have much of an idea as to how to go about doing that. Let's skip ahead to here and see what the math actually says. So select month. So I don't know whether I'm successfully getting all of this. If mod 7 can't actually reach 7, then we never see copper. I feel like mod something is going to return 0 to 1 less than the something. So mod 2 will return either 0 or 1. Mod 1 will return only 0, and mod 0 returns nothing at all. So technically I have to go up to a number. If select is less than 5. Well, actually, hang on. So mod 7 is less than 6, then you get brass. But if the mod 7 is 6, that's the last one, and that is copper, and so I do actually have that part set up correctly. Which means the number I am going to want to use for this mod is 1 more than the final number I compare to. Less than 11, so we're going to have mod 12. I think we're going to have time for one final demo. That is my hope anyhow. It's fun showing some of this stuff to you guys on the fly like this. So that whole statement gets copied and posted over here. Just like this. Boop. And it's randomized because it's not like we have to weight the more successful recent versions more than the other ones. Kind of part of the point of it is that by the time you have enough of these going on, it no longer matters whether you're drawing from the most recent one or a semi-recent one because it'll have the same kind of data in it. Hit save. Hit save. And now I don't need this here anymore, so we can quit out of there. And now we can run it and make one final one. I did notice that if I was able to play the Minecraft that I have, which is like some kind of lunar client or whatever, and it was able to capture the pointer while running OBS, rather than what was happening, which was I'd run OBS and then it wasn't able to capture the pointer, so I couldn't play the game. If it was working better, I'd still be playing Minecraft with you folks. And I'm never really very much for trolling and pranks and stuff. Never really have been. I come from, like, Scandinavian humorless Finnish. Actually, no, it's Swedish who are supposed to be more humorless, but humorless, depressive Finnish blood. So I basically am like, I'm going to build my thing, and if you play with it and make pranks on me, you die. And since I'm not that vicious and savage, typically I don't actually act on anything like that. I'm just like, well, that sucked. Somebody ruined my thing. But yeah, I'd be playing Minecraft if I could. It's just not letting me do it anymore. Because it doesn't capture the pointer when you click into the game. So you end up like clicking outside the window. And you can't do that while like fighting things or whatever. Let's run this with our new Gold to Musk quality standard and see how it does. And do we have a suggestion for size of room? Like, I think what happened recently was it wasn't actually, we'll do a medium-sized room this time. I'm just going to assume or indeed. So this should be producing some sort of vaguely medium-sized room. We've already got 11 updates, so we have a, and look at how reasonable it looks already. Dang. It's shooting for, yeah. No, I appreciate it when people want to do, there's somebody who's been undermining the base that I have on that little island, and I've never done anything about it. Like some of the folks, if I'm streaming, they'll be like messing around and doing stuff and coming up and staring at me or like firing rockets at me or harmless things that are still messing you about. Holy crud, look at how well that's doing. It's been mere seconds and that looks reasonable. That's astonishing. Which implies it can do even better. We're going to let it try. It's 4:38. If I hang out doing this for a little while and like keep up a line of conversation, we should be able to run off the final version, and we'll give it a couple of 100,000 tries or whatever. It's done 13 updates. What that means is that everything is at least a little bit fresh. There we go, 14 updates. So that looks a little wonky. But I'm liking the distribution we're getting here. So what it's going to be doing is trying to come up with superior versions that are still mostly drawn from previous examples, which are in turn mostly randomized values. So doing a pretty decent job of that. What I don't know is whether it's going to sound like an incredibly small room. Haha, Grens, did you miss the whole C# business? No, I will. I've got time. It's 4:40. I've got about 20 minutes before going and having tacos. And I think two things. Firstly, Grens. I ported into the matrix to C#. It used to be coded in GD script. It happens to be a kind of thing where it was helped a lot by porting to C#. Into the matrix got between 10 and 100 times faster. This is the 6x6 version that we're looking at, and it's burning through possibilities at an extraordinary rate. Yeah, the thing that, so it got faster, and maybe you were there for that. What happened today is I have incorporated the genetic algorithm way more aggressively than I had previously done. Way more aggressively. Honestly, I could be fiddling with it in such a way where it was tracking the update and only tried drawing from the update when there were enough of them in there. But is really faster. Like, this is way the heck faster. And the other question, what we're seeing, I can explain in less than, well, actually, maybe it'll take me more than 20 seconds, but I've got 20 seconds, so it's good. This generates reverb impulses. And if I open the thing that I was working with, this program generates little collections of numbers like these. It's sort of using these, but mostly it's making these. These are a sequence of numbers that go into a thing called a householder matrix. Householder matrix is like an arrangement of delay lines where you have to combine them all together in various permutations. So rather than going through them all one at a time or all in parallel, they're kind of stacked up. So if you have a 4x4 matrix, you've got a stack of 4 that they go through in parallel, and then you mix them all into the next 4. Each of them gets a combination of the previous ones into the next 4. And those get mixed into the next 4. And those get mixed into the next 4. And then you recycle it back to the first 4 again. And there's a particular mathematical way of combining them, which means that if they go at like unity gain without any attenuation, you have a reverb matrix that will go forever. You make a sound and then it's just infinite sustain. It's like the old lexicon infinite reverb. And that is what a householder matrix can do for you. And this is a 6x6 householder matrix, which is a slightly weirder way of combining them, but it still works. And we've been generating these based on the new genetic algorithm code that I wrote. And what we got is, let's turn that down nicely enough, is these sounds. Here's the first one that I tried. That's a reverb tank. It's all wet. So you might say that doesn't sound very reverby or sustainy. So I've got a longer one. Still doesn't sound that sustainy, but it's doing its job. And then the most recent one that I did was making a couple of little hacks and changes, doing an even smaller one. And it's sort of the idea is doing small rooms that don't sound like whoosh. Here's a small room. So the ultimate goal is to have it sound exactly like reality, and then to be able to pick whatever size you want in them. Now that might sound like nothing's happening, but this is the original source. So we're making all those reverbs out of that. That's what it really is. And it turns into this. So I picked a very short reverb-less drum for a reason. And there you go. So that's what this is. And again, these ones might not sound like they've got lots of reverb, but the original sound is this. So if I can make it sound like it's in a room, that's pretty cool. People want stuff that sounds like a real legitimate room, rather than just a weird special effect. So this is doing much better than it used to, as far as getting that done. And that's what we did today on stream. On stream for people to watch. And we're currently looking at this one, which is a sort of between those two sizes. It's about a 1,000 seat place, although they're all ending up sounding shorter than you'd think. All of the above. Mostly it's for music, because I make audio for people who make music in DAWs and so on. There's a lot of useful things that you can do with that kind of stuff. But it absolutely can. I intend to build some of these into a game I'm working on that we didn't actually see today, so that I can have a giant outer space sound and reverb. And I'm actively trying to get somebody to help me bring the entire Airwindows collection into the Godot engine. I'm not talking to the right people yet, but I would actually like to be able to find somebody, or that, or I will just lean on Bacon Paul or whoever and be like, fine, I'll do it myself, and then do whatever is needed in order to, because the Godot engine, like we're looking at the Godot engine here, not as directly because that's a plugin, but this is the Godot engine. This is a game engine, and the game engine has, let's see, is there a way that I can look at the, Yeah, Game Engine has audio stuff. You can add effects. I want all of my stuff to be available in a list like this, because you can add effects, and then if you've got the inspector selected, see, that's an effect. It's probably a biquad. It is a cutoff filter. You can set resonance, gain in dB, and so on, stuff like that. You can have that built into your game engine. This is, in fact, literally the audio part of Godot. So I feel like I should be able to have all of my plugins in here. I mean, there's a reverb. If you click on that, you've got, like, this is probably Freeverb. This is probably Freeverb. It's like room size, damping, spread, high pass, dry, wet. There's a pre-delay section. Pre-delay is milliseconds, and apparently feedback. I don't know what feedback has to do for pre-delay. That is, it's defaulting to 0.4. We don't normally do pre-delay as an additional echo. That makes no sense at all. But it's there, and it's set up to automatically start doing it. These are effects. This is a built-in mixing system, and I'd like to be able to put my stuff in there. You can do some fairly, like, see, add bus, load, save as, and so on. You can do useful stuff. I've got a game that I did where I was doing, like, breakbeats and synthesizers in there, just using samples. It is very possible to get that stuff up and running and have it actually do a pretty good job. That's what I did with the game that I did that used the audio bus, but I want my stuff in there, and so I'm going to have to figure out how to do it. Yeah, no, I would. That is a sought-after goal, because you realize if I was able to bring all of my plugins into the Godot engine and it actually worked even partially as well as using a DAW, you can do a lot of stuff in a DAW. And if you were able to run that in a game engine, well, guess what? You could write music that was like super interactive, and you'd be playing it by interacting with the game as if it was like a game. There's a lot of possibilities there. Similar to that thing that people are doing where it's like a command line music language, something that came out of C Sound, I think, and people are fooling around with stuff like that. I forget what it's called, Stellar or something, but that's recently showing up and being neat. But how much cooler would it be if you were able to bring in the entire collection of Airwindows effects into just a Godot program? People wouldn't necessarily know what any of it was. But yeah, I was doing stuff. I wonder if I can actually, it would be quite amusing if I was able to run this while still running this. I probably can. I don't know if I built it into a standalone application though. Let's find out. Maybe it'll be in extras. So, balls up. I do not see it. I do have the thing called cluster fluff. That's not the same. But is it the most recent version? Okay, so standalone program. That's not making any noises. Yeah, that's an earlier version of the program. Yeah, so I'm not going to be able to build and run this for you, unfortunately, but it's like 8 minutes to the end of stream anyhow. So tell you what, shall we just listen to this one as it is? I'm waiting on it hitting another update, but it's not doing it. And if it let's give it another minute or so. I'm waiting on this hitting another update. I can see why getting VST plugins into Unreal would be difficult, is because the game engines are probably looking to have game engine coded DSP. And there's a bunch of stuff that I have, including stuff that I'm being asked to do. Like I'm being asked to do a new version of Distance that has more fine-grained granularity on close-up sounds. But I've got a lot of stuff that could really help game developers, but there is not that big of a crossover, as you can plainly see by looking at what we were looking at in Godot. You can plainly see that those are a bunch of effects, to be sure, but they're the most primitive, like boot recruit level audio effects you could possibly imagine. The one thing I'll say for it is that there's a filter that lets you have resonance. It's not good resonance, but there's a filter that lets you have resonance. So there's that. I think it's basically a biquad low pass. But yeah. And yeah, I will confirm that it looks like the room mic simulator aspect of this just took a giant leap forwards. So I'm going to be clearly nursemating this program and running it a million times over, because I've basically made all of my previous stuff obsolete in a day. But the rewards will be amazing, because I'll start turning out like 14 examples at a time, every single one of which is going to be way better than anything I had before. What's not to like about that? And if it's leaning in a funny direction, all I have to do is change all of those, like this stuff here. Controls 5, Control 6, Control 7, Control 8. These are all the things that tell you what the end result is going to sound like. So having these letters be different gives you a different behavior. Like if the G bloom space sustain whatever is way higher starting off versus way higher ending up, it'll change it between like a hall type effect and a plate-like effect. Some of the other, like naturalness, is ending up being about the same either way. It's BB. Darkness and depth, that's going EG. What that means is that is what is causing this result, where it's bright up front, and then you, because blue signifies what that means. And then towards the end, not bright anymore. That's because it is built in to be going for like B, darkness, depth, is its leniency is E up front and then G towards the end. Also, the midverb density, that is what is causing the center of it not to just be a dense cloud of green, right? I can have it set up so that it is leaning towards having all the echo effects coming in the center. But shape midverb density is what's pushing that away and making it so it's a continuous wash of sound from beginning to end. And there's a spot towards that which is more along the lines of realism, and there's a spot towards that which is, you can tell it to be real artificial. Force early. Force early is what's causing the initial stuff to not be long pause, then all the reverb at once, as if it's like a big echo thing. Because if it's a big echo thing, it will bounce from side to side for stereo sounds. And so force early is what does that. That can be set to different things as well. Priminess is a very interesting one, because priminess, you see the little blue and orange dots in there. I can reward whether it is hitting prime numbers on the outputs of all of these delays combined together. Is what I'm able to do. It fits in here. It controls number 10. Converted from a... The reason it's being converted from a letter to a number is because initially I had this set up so that it was spitting out all the letters associated with each of the settings. And then I could evaluate them later and go, oh, hey, all these ones that ended up really good, this letter ends up being B. Therefore, how about I set that letter to B, because the only good ones that came out were the ones where the letter was set to B. And that gave me a number, but it was able to associate it was able to keep track of the letters by having them be part of the file name. Similarly to how this has numbers, but those numbers are just the initial delay constants. So it's really just a 296, but it's being made up of like 172, 99, and 23, for instance. But that gives it a unique number. So if I have another 296 that happens, it'll have a distinct number. And yeah, that's how this stuff all rolls. So we're not going to see a new update. Here's what's going to happen. We're going to show you this one final one. And I'm going to go a little bit past 5, but not that much past 5. It's going to be fine. Here's how we do that. Open up verbs text. Here's what we're copying our data to. We're not waiting around to see if it comes up with another update that's less stripy. Instead, we're going to hear what this stripiness sounds like. Hit stop, and it copies it to the clipboard, and here it is. Which actually, that was a 701. Huh. Hit save and drag. Shuttle to reject it. Hang on. Okay, so I have to quit out of there now. What's going to be really interesting is when I can start using these to go and refer to recordings of actual rooms like Abbey Road, and then go and find which of my reverbs most closely simulates that once I have them really working well. So final example before going and having tacos. It's going to go a little bit past 5, but that's fine. It's not going to go that much past 5. Here's our 701 seat. Copy that. Paste it into verbs.xs. Build. Copy the file name. We do have the program shut down, so I can replace the component. And open up that brief little text file with no reverb on it, so that we can hear what it does. Then install it. Apply it. Brief little peek of what it sounds like over the laptop. That sounds like a reverb. Save as, command paste gives me the file name. And I'm going to drag that right back over to the main computer and pump it straight into the stream, DI, which I can't do with this laptop, so I'm not doing it. Quit. Close and let's see. Save that, quit out of there. Save that, quit out of there. Here you go. I say that, and yet there's another stage that I need to do, otherwise it won't play back as loud. Namely, and I'm going to want to see what color code it is. File name, batches, pre-normalize. I have to do all of this like 14 times each morning when I'm doing these, if not more often. When I do a lot of different instances, I'm doing it all day long. Overwrite the original file. Oh, we're going to hear. You're going to hear it better than me at first because I'm turning my playback volume down so it doesn't screw up too much by going into the microphone. And analyze is part of my routine, so we're going to do that too. Then I get to quit out of there. reopen this up. This is the most recent one. I'm just going to scroll over to see it, and it is a 15.5 that comes through as a yellow color coding, which is okay, but not special. And having done that, let's hear it. Sounds room-like to me. And we're definitely getting more confined spaces out of here. It's all right. I can do better running it overnight, though. 100 times the options. Very neat. Alrighty. On that note, next time I see you, I will have tried many of these and run them overnight and seen what I could get out of them. So that's going to be an amusing prospect. We'll see what I can do. For now, I actually get to go and have my tacos in a timely fashion because I'm not coding a video game and stuck playing the game, which is a good sign for it being a good game, but on the whole, it's a little challenging. So, on that note, you all are getting the new update to TapeHack this coming weekend, so that should be exciting. And I'll talk to you later. Bye-bye.